Hey guys, I hope you're having a good Tuesday. This is the notes for the rest of the day three related rate stuff with triangles. Um, this question right here is just kind of like a part B to the first question. At what rate is the tip of his shadow moving? So back in class, if you remember, we found the rate of change of the shadow over time was 4/3 feet per second. We did that by after drawing out the diagram, using similar triangles, we were able to create this equation right here. We simplified it to this equation right here, and then we differentiated both sides to find the rate of change of the shadow over time, knowing the rate of change of his distance from the light pole. And we got 4/3 feet per second. So now that I have a relationship between this 5s plus 5s equals 5x, that relationship between s and x is going to allow us to answer this question right here, I think. So let's see. We know that his distance from the light pole is x. This is the distance of his shadow. And it's saying at what rate is the tip of his shadow moving? So the distance from the tip of a shadow to the light pole is what we're looking at. I'm going to use a capital T for tip instead of a lowercase t because we're going to have lowercase t be time. So if I want to know the rate of change of at what rate is the tip of the shadow moving, the rate of change of the tip of the shadow over time is what we're looking for. The only variables here we really have is x and s, and the relationship between t, the length of from the tip of the shadow to the light pole is just the sum of x and s. If we take his shadow length plus his distance from the pole, we'll see that the tip of his shadow is the same thing as just taking his distance from the light pole and adding it to his shadow's length. So we're still using s for shadow. Now, if I just take the derivative of both sides with respect to time, we get the rate of change of the distance of the tip of a shadow to the light pole over time. The derivative of x is just dx dt and ds dt. So the rate of change is just the rate of change of x plus the rate of change of s. The rate of change of x from the previous question we know is 4. And the rate of change of s is 4/3. So it's just going to be 4 plus 4/3. Let's see, that's the same thing as 12/3 plus 4/3, which is going to be 16/3. I think we're in feet per second. Yes. Okay. So not too bad. The equation t equals x plus s, differentiate, plug in, and we're able to solve that no problem. Now here's the a very popular calculus 1 related rates question. Jake leans a 25-foot ladder against his garage. So let me just draw that. And I don't know if it's going to the top of the garage or not. It's probably not going to matter. So this is the garage. It's 25 feet. After he climbs up the ladder, it begins to slide down. So now the ladder is sliding down, and it's sliding down at a rate of 3 feet per second. So we'll label that in a second. How quickly is the bottom of the ladder sliding out? So how quickly is the bottom of the ladder sliding out away from the base of the garage when the top of the ladder is 20 feet from the ground? So we'll say that the top of the ladder is 20 feet from the ground. So we'll call that B. We'll call this C. So down here, the rate of change of B is this speed right here. So the rate of change of the ladder going down, the rate of change of B over time is 3 feet per second. Now be careful here because the distance from the ground is getting smaller. So that means the height is decreasing. So it's going to be negative 3 feet per second. If we call this distance A, we're looking for the rate of change of A over time. So this is what I want to know. how fast that part of the ladder is sliding out. Again, I know not sure what A is, but B is 20 and C is 25. So we can Pythagorean theorem to get A, no problem. A squared plus B squared equals C squared. So A squared plus 400 equals 625. So A squared equals 225, which gives me 15. So if A is 15, we got A, B, and C. Do I have an equation that relates the three together? I sure do. A squared plus B squared equals C squared. Now, one thing to recognize here is A and B, those distances are changing, but C is the ladder. The ladder isn't changing. The ladder is always 25 feet. So A and B are not constant, but C is a constant. So this is really just going to be 25. So when we do take the derivative of both sides, the derivative of the left side, 2a times the rate of change of a over time plus 2b times the rate of change of b over time is going to equal, well, the derivative of a constant is 0. So plug in a, b, and the rate of change of b, and then we'll be all set. So 2 times 15 times dA dt, which is what we're looking for, plus 2 times b, which is 20, times the rate of change of b, which we know is negative 3, equals 0. And now we just got some algebra to do. That's going to be 30 dA dt minus 6 times 2, is that 120? Equals 0. Add that to both sides. Add the 120 to both sides, and then divide both sides by 30. 120 divided by 30 is 4. So 4 feet per second. That's how fast the bottom of the ladder is sliding out away from it. So it makes sense that it's positive because this distance is going to get bigger as the ladder slides out. Anyways, so those are the last two examples. You guys have homework. I'm not sure if I assigned it yet, but I will soon. And it's just this right here, related rates, homework 3. And you guys will do that on Tuesday. We will not have a Zoom. And if you have any questions, just shoot me an email, and I'll see you guys on Thursday.